Okay, I'm gonna pick one. Hard, no hard. I should. Okay, and then pick one. Medium. It's a JavaScript, so I'm gonna skip this. Yeah, give me Python. Medium question. Hard again. No. Uh, I'm not lucky today. Pick one. Yeah, hard again. That's so weird. It's not really weird, but just by chance. Getting hard. What's happening? Always giving you hard. I don't want to be hard. Just give me medium. Why? Why I'm just pulling the hard in five in succession? That's weird. Give me. Oh, okay. This medium. Sure. That's great. Yeah, this is also algorithm question, so I'm gonna reset the timer and switch to Python and let's start this. Okay. So the question is the number of subarrays with odd sum. Okay. Given an array of integers, return the number of subarrays with an odd sum. Since the answer can be very large, return modular blah blah blah. And if I'm given 135, I'm supposed to return 4. And subarray gonna be 1. I need. What should I do? Huh? What should I do? Return the number of subarrays with an odd sum. So this is just listing all the subarrays. And then this is listing a sum of each subarray. Right. And then what we found was 1, 2, 3, 4. Yeah, that's going to be 4. I see. Okay. And then in this case, we have this is all the subarrays. And then we actually don't have any sum which has odd sum. So that's supposed to be 0. And in this case, there's no answer. So there's no explanation. So I actually don't know, but it looks like suppose return 16. Length should be up to 100,000. And array doesn't contain 0. It doesn't contain negative. Sure. Yeah, so yeah, I don't know how to solve this, but I'm gonna think about it, how to do it. So because this is subarray sum, so that makes me think about prefix sum. Just following the kind of prefix sum, like the pattern of algorithm question. But is it really helping me? So if I given R is 1, 3, 5, and then if I have prefix sum, that's gonna be 0, 1, 4, 9. And right. And I supposed to have 4 variation from it, so that should be 1 and also 4 minus 1 and and also 9 and 9 minus 4. So this should be 3. This is 5. And this means that just 1. And 3 means just 3. And 5 means just 5. But 9 means, so I'm just getting this one. So 9 means 5. So I'm getting 1, 1, 3, 5, 3, 5. Yeah, so I think prefix sum can give me, like after getting the prefix sum array, I just take the difference of each element, and then I can get I feel like I feel like this is very similar to the what I've solved previously when I created video, but maybe it should be different question, but yeah, I can keep doing it. So so right, so I can basically I can just take the difference, and then that's going to give me the sum of some array somewhere in the array. And then if I get the sum, I can just take the modulo by 2. And if the remaining is 1, it is not 0, it should be odd. So far, okay. I can get all the odd sum. But from here, I need to count the number of subarrays with odd sum. So I think what I have to do is what should I do? Am I keeping each number to the hash map maybe? Is that what I'm supposed to do? Um, yeah, I think that's what I'm supposed to do. Like hash map. If I have hash map, then the key should be prefix, if it's sum, and then the value should be the index. What's going to happen is 0 to be minus 1, 1 to be 0, 4 to be 1. And then 9 will be 2, right? Right, and then right. So, for example, if I'm index 0, current number, I want to efficiently get, no, that if I iterate all the keys, that's going to be n squares. But I don't want to do n squared because this is 10 to the power of 5. So if I create all n square, I think that's going to be TLE. So I think I need to find out a better solution. I think I'm pretty close, but let's say, so what I'm seeing here is at 9, I actually have two combination I can find. What should I do? Mm, um, so at one, I can find one combination, one minus zero. Oh yeah, so this is actually not correct. It's one minus zero. And at four, I can have one combination by four minus one. And at nine, I can have two combination by nine minus zero and nine minus four. Mm, yeah. Um, I mean, I want to efficiently find zero and four. Is it again remaining stuff? Or is it remaining stuff? Maybe. Um, yeah, if I iterate each key, that's going to be all n square. Um, I get prefix sum, and then if I get previous with prefix sum, uh, I can take the difference of current prefix sum and previous prefix sum. And if the difference is odd, I can increment the answer. So I want to efficiently get that. What should I do? Hmm, is it? Is it two? Is it 2 pointer? Um, yeah, like I stopped my thinking at the hash map, so maybe I can think about more about the hash map, how this is going to be helpful. So, um, so for example, at one, I already have one zero. At one, at four. No, it's gonna be. Is it can't be n square? Ah, it's already 12 minutes. Ah, damn, I'm so slow for this question. Um, maybe it's remainder maybe. But how can I get the remainder? Well, I don't have a divisor to compute the remainder. Oh, yeah, I can. Subarray sum. Yeah, I don't want to do it in square. Yeah, coming back to the naive approach, I think you can just pick the starting position and ending position and just get the sum over there. Uh, that's going to be n to the power of 3. So maybe n squared is okay approach? I don't think so because this 10 to the power of 5. I think it sounds like there should be a kind of better approach. Like if I have prefix sum array and we don't have negative or zero numbers, so we are guaranteed to have increasing ordered prefix sum array. Is that helping me anything? Mm, oh, don't know. Yeah, I think I'm gonna just create a naive approach, and I think that's gonna be really that's the only thing I can come up with. Oh, that's the only thing I can come up with. Um, yeah. So it's always increasing, and prefix sum is definitely going to be unique because there is no zero and minus. So if I create the hash map, the prefix sum key is always going to be unique. Yeah, I think that's also another hint, but yeah, I think let's try. Yeah, let me try any square approach and then let's see what's gonna happen. Okay, so prefix sum 0. Uh, prefix sum 0. So this is like prefix sum to index, and I'm gonna have prefix sum, and this I'm gonna do -1 and for I in length array, and prefix sum is incremented by current number, and I'm gonna save this one to index in prefix sum, save this index, and I'm gonna have this hash map, and I'm gonna have a variable to return, and then I'm gonna return this variable. And when I iterate again, you know, and no. What am I doing? I need to do that while in the first folder. So I'm gonna have this one, and for e value there, in prefix sum to index the items, and I'm gonna take the difference by prefix sum minus previous prefix sum, and if this modulo by 2, this is odd, I'm going to increment it by 1. No, I don't feel like this is the right answer. Yeah, it's weird because I'm not using this index that I'm saving. So, and then after this, prefix sum to index, I'm going to save current prefix, and I'm going to save the current index. If I run with the test case, it's working, but I don't, yeah, this is going to be too early, definitely. Yeah. Yeah, just because just 10 to the power 5, uh, right, just nested for loop. So time limit exceeded. Yeah, I think there should be like n O of n approach, I guess. And I think, yeah, and obviously I'm not using the index anywhere. So um, there should be some kind of way to use the index to count. Uh, is it two-pointer? Like up to 9, I want to get the idea of I have two subarray without doing the iteration. How can I get that? Am I saving? Am I saving diff instead? Is that? Am I saving diff to the password? I've never done that, so I don't know whether that's gonna work. So what's gonna happen is, so key as diff, and value is gonna be count. So difference 0 is 1, and difference 1 gonna be 1, and difference 3 gonna be 1. Hmm? I feel like I'm doing pretty weird stuff. What? Oh, it's already doing it, and I'm so slow. This is really terrible. I thought I'm kind of on the good direction, but I just don't know how to get. Oh, I'm so dumb. Oh, I hate myself. Mm, yeah, there should be over end approach. Um, how can I do that? It's taking. How can I efficiently get that? Uh, am I counting even or odd? Is that what I'm doing? Is it what I'm doing? Is it? Is it? Is it really? So this is gonna be odd minus even, and this should be even minus odd, and this should be odd minus even, and this is odd minus even. Is it? Is this like using some kind of math? Also, what's gonna happen like if I do odd minus odd? So for example, like I don't know, 5 minus 3, that's gonna be 2. That's gonna be even, and even minus even, that's like 4 minus 2 is gonna be 2. That's even. I see. So if I see. So if I have like one odd, one even subtraction, that's guaranteed to be odd. But is it really helping me? Is it really helping me? So maybe I'm counting the number of prefix which has even and odd. Yeah, maybe that's right. So when I'm at one, I have zero in the hash map, which is we only have one even, and then current prefix is one, and that's difference between even and odd, so I can increment one. And then now prefix sum is going to be one, so I'm going to increment odd, going to be one. And when I'm at three, um, uh, prefix sum going to be four, and I have one odd before, so prefix even an odd pair, so I can increment one to the answer variable, and then now prefix is going to be four, so I'm going to increment even to two, and then now when I'm here, prefix sum going to be nine, and nine it's odd and is even to two, so I can form two pairs, so I can increment answer variable by two. Oh, that's the way it's up. Okay. Ah, no, God, I should have discovered that earlier. Like I already spent like 25 minutes, and then eventually I found out. Ah, damn it! I just never like faced this kind of question. But I think that's the way to solve it. So I don't need to have this hash map. Just I just say like counter, and uh, but what should I do? So like I'm directly type like even. Let's use one as even, and I'm gonna use one as odd, and zero is so I have one coming from prefix sum of zero. Yeah, maybe that's the way. Yeah, maybe that's the way to solve. So if prefix sum divided to, so if this is even, or if this is even, I'm gonna increment answer by counter. If it's even, I'm gonna get odd. And if the prefix sum is now, if this is odd, in that case, I'm gonna get counter of even. And then eventually I'm gonna save. Yeah, I need to save current prefix to the hash map. So in this case, it's even. So I'm gonna increment counter of 0 by 1, and counter of this is odd. So I'm gonna increment odd by 1. Okay. How about now? How about now? Yeah. Yeah. Of. Oh yeah. This is. I think this is just the modular stuff. So what should I do? I'm gonna define mod and 10 to the power of 9 plus 7. So answer equal answer plus current number in modulo by mod, and answer gonna be incremented by answer in by modulo, like that. Oh yeah. Oh, okay. Shit, I spent over 30 minutes, but if I could have found out this kind of simple math trick, um, it's very simple code to compute the number of subarray, which is awesome. But I think I just didn't have much experience about this type of question. Like, yeah, like if what's gonna happen if you take the difference between odd number and even number, or what's gonna happen odd and odd, and what's gonna happen between even and even. I think it's not really complicated math, but just if I had much experience with this type of question, I think I was easily find out. So runtime is obviously that's the O of n because it's just one for loop, and then just accessing the hash map value. So that's the O of one. And the memory, I think memory is just actually just constant because we always have the key, two keys, so it's not going to scale by the length of the array. So um, I think this is just disappointing. I spent 30 minutes just too long for this question. Like if I had kind of get the idea how to solve it, I think I could have solved, I don't know, maybe 15 minute or like, yeah, 15 minutes should be kind of reasonable amount of time. But I just wasted a lot of time just sticking to like prefix sum array. But basically, yeah, basically that's it.